Okay, I think we have a quorum, so we can get started with another Gazebo community meeting. Welcome, everyone. As always, this meeting is being recorded and it's going to be posted to YouTube and Vimeo. So if you don't want your face showing up, just be sure to turn off your camera. So today we're going to have a presentation from our friends at Canonical, who are going to talk about how they're packaging Gazebo as snaps. And here's the agenda for today. We're going to start with some quick announcements, then we jump into the presentation. Towards the end, we are going to share some news that we saw online and Kat curated for us. And then if anyone else wants to speak about something else, if we had time at the end, be sure to add items to the agenda here. So let's start with the announcements. So the first one is that we are 2 days away from the feature freeze for Gazebo Garden. That's going to be released in the end of September. So the timeline is here. This has been shared before. Anyone can see it. It's public. So the feature freeze is this Friday. And what's going to happen is that we're going to kick off the choosing the name for the next release, which is going to be Gazebo H, and some word that is related to architecture. Then we're going to be merging forward everything that is on Citadel and Fortress to the garden branches. And something that we're going to be doing differently this time for people who have followed our releases before is that we're going to create the stable branches straight away. So next week, we're going to have the GZ Math 7, GZ Sim 7. Those branches are going to be created. And that's a difference from previous release cycles, just because our release cycle is so long this time, the feature freeze is so long. So what's going to happen, if you have a pull request that is currently targeted at main, all the bug fixes can continue being targeted at main, and they can be merged until code freeze, so they have another month to be merged, and they're going to be labeled with a beta label, so we can keep track of them and keep track of what bug fixes have been added afterwards. So this is really the focus for the next month. After we call feature freeze, we're not adding features anymore to Garden, and we're going to be focusing on ironing out the bugs before we start the QA process for the pre-release. If there are backwards compatible features targeted at the main branches and they don't get in by this Friday, the author of that pull request has a couple options. They can either retarget the feature to the new stable branch, but that's not going to be merged until after the stable release, so until October, 2 months from now. If you can wait and if you can keep up with the changes that will happen in that branch and keep that pull request updated, you're welcome to do so. Another option is to retarget it to main, merge it into main, and after the stable release, backport it to Garden. If you have any breaking features targeted at main, they will have to continue targeting main, which means that they're going to come in the next major release. They cannot come into Garden. So anything that is breaking and is a feature and is not merged by this Friday cannot get into Garden. So to make the main branches receptible to all of these changes and people can keep developing breaking changes, we're going to be bumping all of them to the next major version. So, Gazebo, the main branch on Gazebo Math right now is in version 7. We're going to be bumping that to version 8, and then it can start receiving breaking changes as usual with TikToks and whatnot. As those beta pull requests are merged, we are going to start making pre-releases, and then we update the documentation to use the pre-releases. So this is what's going to be happening during the next month until we enter code freeze 1 month from now. So that's it for the feature freeze. Another thing that has been happening, and I know people have been following, is the renaming of Ignition to Gazebo. So all of the changes to the source code on Garden have been made, and we are ready for the feature freeze on this front. So you can track everything that has been changed now here, and we have a tutorial migration guide in the works that we're going to be publishing soon for people who want to start picking up the pre-releases and trying out Garden as we start making the releases for that. So that's all on track. And another announcement for folks today, the ROSCON program has been announced. It's live if people want to check it out, and registrations are open. So if people want to go attend ROSCON in person in Japan, the conference is going to help and sponsor your visa, and you can go attend the talks live. So be sure to check it out. Okay, without further ado, let's get into this month's focus. So I have here Jeremy Drey, who's going to be talking about how the folks at Canonical are packaging Gazebo as a snap. So it makes it really easy to install Gazebo in a multitude of platforms. So it's very exciting to have you here, Jeremy. I'm going to stop sharing my screen and you can take it away.
Hi, thank you for the introduction. Let me share my screen. All right. So, hi everyone. I'm Jeremy. I work at Canonical. I'm a software engineer in the robotics team. And today I'm here to give you a brief presentation around Snap and the Snap ecosystem. And in the second part, I'd like to demonstrate the Snap we've put together for Gazebo. So a slide deck and a live demonstration that's going to go just fine. Just a brief word about Canonical. So we are a global company founded in 2004. We have more than 800 employees and growing, and we are present worldwide at 40 plus countries and counting. We essentially cover the entire compute continuum. We've notably Ubuntu desktop, Ubuntu server, our OSs that you all know very well. But we also have other stacks such as OpenStack and a lightweight Kubernetes distribution. We work with a lot of big names in the computer industry, and some of them are directly related to IoT and robotics. You may recognize a few familiar names on the screen. And of course, as you know, Ubuntu has been the home for a lot of great open source projects that have flourished over the years. The OS has been supporting a lot of developers and open source community and different initiatives. And of course, this includes ROS and Gazebo. So Canonical, and more specifically the robotics team at Canonical, we are part of the technical steering committee for ROS 2, and we are leading the security working group for ROS 2 as well. Recently, we have announced the ROS Extended Security Maintenance, or ESM. That is an offering we provide in collaboration with Open Robotics, and this essentially offers you an extra 5 years of maintenance for your ROS distributions. So Kinetic is still receiving security patches from Canonical through the ROS ESM offering. But coming to today's topic, snaps, what are they? Well, the short version is that they are a mean to package and distribute your robotics applications. Before saying more than that, I'd like to show you just a brief video that showcase how to set up a Turtlebot 3 the regular way, following the upstream documentation, versus how to set it up with a snap. So you have and of course, this is setting up a brand new, fresh install of OS on a Raspberry Pi 3. So on the left, you have to enable the ROS PPS, you have to install all of the different packages, whereas on the right, we simply install the snap, everything comes bundled. This particular snap runs as a daemon, so as soon as it is installed, you have all of the topics up and running, all of your ROS node up and running, and you're ready to rock. So snaps, that at this point, I'd like to make the distinction between three different essential tools in the Snap ecosystem. There are the snaps themselves, but there's also Snapcraft, which is the tool to build your snaps. And then there is the Snap Store, which is the online store to distribute snaps. And then you have a plus one, if you wish, that is Ubuntu Core, which is an Ubuntu distribution that has been tailored for IoT and robotics. I'll come back to that at the end of this presentation. One quick thing to note is that you don't need Ubuntu Core to run snaps. Snaps run on Ubuntu Desktop, Ubuntu Server, but also a couple dozens of other Linux distributions. So you don't even have to run Ubuntu to benefit from snaps. So snaps are ideal to package your ROS application. They've been really designed to pack and publish applications, and I insist on that. You're not distributing libraries, but full-fledged applications. They have a native support for ROS and ROS2 applications, as we will see in a bit. So it's really easy to package your ROS application as a snap. And it has a streamlined deployment schema. So it's really easy for you to deploy or to offer to your users different versions, show you maintain different versions for different ROS distributions, etc. But let us have a look at how do we package snaps. So the snap packaging is driven by a YAML file that is consumed by Snapcraft. And what you have on screen is essentially all you need to package a ROS2 talker listener application into a snap. So on the top third of this YAML file, you have a bunch of boilerplate code that simply that looks very self-descriptive. You have the name of the snap, the version of the snap, a short and a longer description. You also declare a base that's essentially the runtime environment for your snap. So here we are using Core 22. That's the snap equivalent to Ubuntu Desktop 2204. You also define a confinement for your snaps. Snaps are by default, or at least they're encouraged to be strictly confined, meaning that they don't have access to any resources on the host machine. Then in the middle there, we declare an application. So that's our ROS2 talker listener, and that may look very familiar. We are simply invoking the ROS2 launch command to launch a demo node CPP talker listener that comes from the upstream ROS2 demos. Then we have plugs that are essentially permissions for your application to access the resources on the host machine. Otherwise, again, your application is confined, it cannot. So here we are essentially giving our application the permission to access the network and network binding on the host so that ROS2 topics can actually flow in and out the snap itself. I'm not going to detail that. The extension that essentially adds some more boilerplate code that are common to all ROS2 humble snaps, avoiding you some writing there. And coming to the last chunk of this snippet, the parts, and these are a build environment where you essentially build your application. And this is where the native integration comes into place. Snapcraft interact nicely with call count, Catkin, and all of these familiar tools so that you can actually pull your source file directly from GitHub, and it will be able not only to build it, but also to fetch all of the build dependency to build your application, all the runtime dependencies, so that they are nicely packaged within the snap as well. And yeah, that's pretty much it at this point. So this is a very simple example, but the full-fledged Turtlebot 3 snap is not much more complicated than that. You declare application, expose some launch files, and you're ready to rock. So this being said, you use this YAML file with Snapcraft to build your snap, and once your snap is built, you can push it to the store, and essentially anyone in the world can then install your application on their machine, be it Ubuntu or not, be it the right, so to speak, the right Ubuntu version or not. You could definitely run a ROS2 humble snap on Ubuntu 16.04 if you want to. Not only do they run cross distribution, but also cross versions. This being said, what does Snap offers in terms of feature? So not only do they bundle your application together with all the necessary dependencies and do that in a nice, strictly confined containers, but they also come with features such as safely moving forward and backward in terms of snap versions. So if you install a new snap version, you can actually roll back to the previous version very easily, saving all of the data and configuration from one version to another. You can update from different tracks, meaning that you can distribute again your snap across different channels. Think of it as boosted Git branches, if you wish. So you have different branches, and on each branch you have different risk level, stable, candidate, beta, and age. So you can easily switch from, let's say, Gazebo Citadel to Gazebo Fortress. All this update falls, it automatically and gracefully roll back to the last working version of the snap. So an automatic update is never going to leave your machine into a broken state. It automatically rolls back to the previous snap version. And maybe most importantly for those deploying robots in the field, snap updates are delta updates, meaning that you only actually download the delta difference between a version and another, rather than the whole full-fledged application. So really, you get delta updates, you get device management, you get a bunch of usage analytics to know about your user base, so you know which distribution they're running your snap on, at which version, etc. And this comes with a whole ecosystem, and an ecosystem that we are now trying to build really around ROS as well, and robotics at large. Right, so the last bit I want to touch is Ubuntu Core. Again, that is an OS that's specifically tailored for IoT and robotics. Essentially, the way it differs from Ubuntu Server or Ubuntu Desktop is that not only does it have a much smaller footprint, but in Ubuntu Core, essentially everything is a snap. So we've seen the benefits that Snap brings to your application, and we extend these benefits to the applications, the OS itself, and even the kernel. Everything is a snap. So you can update your kernel, and if anything goes wrong, it automatically rolls back to the previous kernel version. And the same for the OS, and of course for the rest of the applications. And what's really neat is that everything is confined, nicely, cleanly separated. So a rogue application is not going to compromise your entire system, or a dependency conflict is not going to break your whole installation, right? You can definitely have humble snaps, ROS2 humble snaps running alongside ROS2 Foxy snaps, if you wish. As I was mentioning, Ubuntu Core has a much smaller footprint than Ubuntu Server and comparable OSs. And we've just recently released Ubuntu 22 that comes with a bunch of new features, such as validation sets or remodeling, so that you can brand a given image to your particular device. You've got quota groups, so you can set the particular snap to have limits on the resources it can use, be it memory, CPUs, etc. You have a factory reset, so you can factory reset your entire device while saving data and configurations. And finally, of course, it comes with a bunch of performance improvements, especially on boot time and execution times. More about that on the Ubuntu blog if you're interested. So to summarize, Snap, Snapcraft, SnapStore, Ubuntu Core, that's an entire ecosystem that offers a seamless transition from hacking together your latest algorithm on your desktop to deploying it at scale on the field securely. And this concludes this first part of the presentation. Do you have any questions so far before we move on to the Gazebo Snap per se?
I have a question.
Please.
Thanks, Jeremy. Out of curiosity, and based on a diagram that you showed, correct me if I'm wrong, but are you still dynamically linking all the different libraries within the main application in the Snap?
In the Snap, everything is still dynamically linked, but dynamically linked within the Snap. So you're not linking anything on the host machine, right? All the dependencies and everything comes bundled within the Snap, which is its own tiny runtime environment.
And is the idea of still, because in my mind, sounds like more natural to use static linking inside, but is the reason because you might have still within the same Snap potentially multiple applications or something like that that could benefit from dynamically linking? Or I guess what is the main motivation for doing that as opposed to static linking?
So the snaps or the ROS snaps really are relying on the ROS tooling. So we are relying on Catkin, Qualcomm, ROSDEP, but also CMake, G++, etc. So we are reusing the whole build tool chain from ROS, and that results in dynamic linking. Now, if you wanted to do static linking, you actually could do that, and you could do that in a very transparent manner, just as you would do on, locally on your machine. But that takes some extra effort on the Snap developer side, right? Now, what would be the benefits? What do you have in mind?
I don't know, maybe the usual thing where if you have like a shared library, maybe load times and things like that. But I guess Snap is agnostic that way. Maybe like sounds like you don't enter into a shared library or a static library. It sounds like you reuse whatever tooling it's there. So is that right?
Yeah, so again, the Snap is, to build the Snap, we are reusing the ROS tooling, and then the Snap it's a container, really. It's a tiny runtime environment that bundles not only your application, but all of its dependencies. So whatever you do inside, whether it's dynamic or static, that's just fine. Again, you're not linking to anything on the host. I'm not sure I address your question, but
yeah. Thanks.
Yeah. All right, thanks.
So I have a question about dependency. So you said that for the ROS ecosystem, you use like ROSDAP to get the dependencies, but Gazebo doesn't have a package.xml. How are you guys figuring out what are Gazebo's dependencies when you build the snap, and how do you pull them in?
Right. Actually, I should have opened the Gazebo snap. Let me do that. For the snap, we have simply hacked together a bunch of package XML for the different Gazebo packages, so that we can reuse the whole ROSDEP shenanigan.
Okay. Do all of Gazebo's dependencies actually have ROSDEP keys? I've never checked actually. Did you guys have to also create some ROSDEP keys that didn't exist?
Just a second, I'm opening the actual snap file for Gazebo. So we've seen such a YAML file during my presentation, and this one it's on GitHub, canonical Gazebo snap, and that's the one that's driving the packaging for Gazebo. So you'll see a lot more text, of course. That's a much more complicated application, but nothing crazy there. We have a part Gazebo. We're building from source because we're hacking things together. We have a bunch of call counts in make args. Something that we didn't see during the presentation is that you can specify build packages manually that are packages required at build time. And there you may see a few dependencies that are not directly specified in the package XML we've hacked. Ruby and a lot more. Similarly, you have stage packages that are packages only required at runtime, so they are not present at build time. And then, we are creating some artificial package XML to pull a bunch of dependencies. But maybe those are only the ROS to control, etc. So to answer your question, it's a mix of both. We are reusing some tooling with ROSDEP and creating some artificial package XML, but we also have the opportunity to manually specify dependencies that are required either at build time or runtime.
Got it. Thank you. Yeah, that answers my question. So those packages there, those stage packages, they're being pulled with apt?
Yep,
yeah,
absolutely. Okay. And you can define some third-party package repositories, just as you would locally. This one specifically is for the Dart and Ogres. So again, to put this file together, we've really just followed your installation instruction, right? We're installing the same packages as you do in the online documentation, and that was basically 80% of the jobs done for packaging Gazebo as a snap. And that also shows how easy it can be to package a fairly complicated application such as Gazebo into a snap. And there you have the different runtime applications that are exposed. So that would be the IGN CLI tool that we've renamed GZ following the ongoing renaming. But also for convenience, we've exposed two other commands that are the ROS IGN Gazebo create for the entities. We'll see that later during the live presentation. and the bridge to ROS. Again, that's for convenience, but we placed ourselves in the shoe of a Gazebo snap user, right? Now we want this snap to be used, so it should be as convenient as possible. Right. Any other question?
I actually have one. So I think we looked into snaps before, and there was still kind of a open question or a user story that I think wasn't exactly addressed, and maybe it's changed. It's been a few years. So
where you're going there.
Say what?
I know where you're going there.
I think you and I may have actually had a conversation about it.
Yeah.
But so like obviously Gazebo is very driven by user plugins and user systems, right? People develop their own shared libraries and want to load them into Gazebo. And I think at the time there wasn't a way to really do that with snaps, aside from basically, building an entirely new snap. So if we had like a competition or a customer wanted to have some special plugin, you basically have to create an entirely new snap around that custom application. Is that still the case, or can users load like custom plugins into a snap-based distribution?
So at the moment, it is still a limitation. This particular Gazebo snap does not support custom plugins. But that's not the end of the story. We are working on the Snap and Snapcraft side on a way to natively support plugins. So there is already a way to do that, but that's not really seamless, if you wish, not for developer, neither for end users. So that's something we're working on. And essentially what we are envisioning is that you would have your main Gazebo snap that ships Gazebo, etc. And then you would have a bunch of Gazebo plugins that are also distributed as snaps and that can seamlessly connect and interact with the main Gazebo snap. Again, that's future work, and we are very aware of this difficulty, and yeah, that's one of the focus we want to work on, and that's not going to be only beneficial to the Gazebo snap, but also to any ROS snaps, really, because that's a common pattern that we find a lot in ROS.
Yeah, I would think even, something like GIMP, right, where people have like other like visual plugins or Blender, right? So you have sort of a base binary, but then you have this sort of like secondary community of plugins. So yes, no, I'm glad that y'all are thinking about that as you go forward. Yeah,
absolutely. And that's one of the few limitations we very explicitly disclosed in the release and announcement of this snap. Any other question? In the meantime, I'm going to switch screen. Let's see. All right. So bear with me here. I'm going to try to give you a live demonstration of the Gazebo snap. Can you see my screen fine?
We can see your terminal.
Yep.
Yeah.
Yep. All right. Let's zoom in a bit. So what I'm going to do is to show you how easy it is to install the snap, to set it up, and run a couple demonstrations. So first, I'm going to simply start a new VM that runs Ubuntu 22, just to show you how simple it is to set up the snap on a brand new machine. So we see the VM booting. Let's give it a couple of seconds. There we are, Ubuntu 22.04. I'm not cheating. That's a brand new VM. There is no ROS installed. And I'm gonna install Gazebo Snap. Is Gradle data. Yeah, installed. It's gonna go much better. I'm issuing the command to install the Gazebo Snap. Since that's a brand new VM, it's going to also pull a couple of the snaps, such as snapd, the snap daemon. It's also going to pull the core 22 snap. That's the runtime, the command runtime environment for any core 22 based application. So let's give it a few seconds here. Yeah, that's all running VMs on my laptop, so it's not chop, right? Right, downloading Core 20, sorry, it's downloading Core 20 runtime environment, downloading the Gazebo Snap from the Citadel data channel. So again, that's something I mentioned a couple of times earlier. You can distribute several versions of the same application, and users can really easily switch from one version to another, specifying the channel. So that's analogous to your Git branch, if you like. And then you can specify a risk level, so stable, candidate, etc. Without different risk level, meaning different grade at which the particular application is released. It's really a promise between the developer and the end users, right? Stable should be stable. Right. Gazebo Snap installed. Is so we see Gazebo Snap, some description, different version, and it is installed. So what we do with that? Maybe we can run a quick demo. Yes. Across. Hey, what do you know? It actually runs fine. Let's see if it actually runs. Yes. Not cheating. That's not a screenshot, right? All right, that was cool and all, but let us move on to a more interesting demonstration. Just gonna stop the VM, otherwise it's gonna load on my laptop. So for this demonstration, I've set up a new VM. New demo. The virtual machine that I've pre-set up with ROS2 and all the good things with the snap as well. And what I want to show you here is the integration with ROS2. Right. Let's give it a couple of seconds. Okay, so on this machine, I do have Foxy installed. I also have a workspace there with a tiny project that, again, you can find on GitHub that simply showcase the integration of ROS2 controls and some demos with the Gazebo Snap. And if you guys have ever looked at those demos, you've seen that Gazebo is launched from a launch file. Same thing here for the snap. So we have the diff drive example launch file. And just really quickly, what we see here is that the ignition entity spawner is launched from the Gazebo snap using the convenient command I showcased earlier. And further down, we are also launching Gazebo from the snap simply as a command. So will this work? Let's see. I'm gonna launch the very launch file I just shown you. In the meantime, in a different window, I'm simply gonna run the diff drive example. So soon again. And then diff drive example, and what do you know? It works. So we're driving tiny diff drive based robot in Gazebo. Nothing fancy here, but that's all coming from the snap. All right. One last demo I want to showcase is, again, the integration with ROS2. This time using the bridge between Gazebo and ROS2. Workspace. So I'm gonna download a world model from the online Fuel Gazebo Sim store, I guess. Not sure how you guys call this. And open it with the Gazebo. It is loading. Let's launch the rest of the demo. So there, check what's up with the topics. Again, from the snap, we're actually exposing the Gazebo CLI tool. So you have access to all of the Gazebo commands, right? Such as topics and listing them. Okay, so it's started. So let's see.
It's singular topic.
Oh, my bad. Yeah. Okay, so we have all of our Gazebo topics. So now I can and the bridge from the snap again, parameter bridge. I'm gonna bridge the pose from the robot to a ROS2 geometry message pose. Let's see if we have any topic on ROS2. That's it. There we go. speak. Echo. Oh, you know what? I know what's going on. I didn't launch the simulation. Oops, wrong tab, of course. But we did receive a few messages. So that really concludes my brief live demonstration. I'm happy that everything went well. I hope that you found it interesting and that it did showcase how seamless the integration with the Gazebo Snap can be. I mean, up to 2 very tiny chunk of Python, you would use it just as you would use the regular Gazebo from the dev installation. And with this, I can ask you if you have any questions.
Thank you, Jeremy. That was a very nice presentation and a great live demo. Any questions for Jeremy? So just to check my understanding, Jeremy, so the even though users cannot use custom plugins, they can't like write a custom plugin and load that into Gazebo. They can load custom SDF worlds. They can launch custom ROS launch files. So it's just anything that links against code that cannot be used, right?
Yeah. Yeah, absolutely. And that comes back to the previous discussions we had about dynamic linking, static linking, and the question from Michael. Essentially, anything that's a dynamic library, you cannot load it into Gazebo, because Gazebo being, or Snaps really being a self-contained, confined container, it cannot, of course, load libraries from the host machine. That would defeat the purpose of confinement. But again, that's something we are working on. But yeah, your SDF models, your entire worlds, straight from the online fuel libraries, that works just fine. We've packaged within the Snap all the ROS2 controllers bits and the bridge between Ignition and ROS2, so you can actually use it with ROS2. Just like Gazebo, you can also use it in a headless manner. So something that may resonate with some of you is that I've just shown you how easy is it to set up Gazebo on a brand new Ubuntu 22.04 image. So you could very, very easily spawn up Gazebo with the Snap on the cloud. I know you guys have been using such kind of setup, and hopefully using the Snap will make that even easier.
Is there any gatekeeping with releasing a Snap? Like, what is necessary for someone to release a Snap? Do you need some like authorization? You know, comparing to, for example, creating a Debian package that goes upstream into Ubuntu. Is there something like this there, or is it anyone can create a Snap at any time?
Anyone can create a Snap at any time, and you can publish a Snap anytime on the store. I briefly mentioned earlier that there are ways to give some permissions to your Snap to access some resources on the host. There are resources that are not harmless, but that are less dangerous than others. So if your Snap was to access, I don't know, a ZFS pool on the host machine, that would require some specific permission that has to be pre-approved by the Snap Store team. But I mean, that's a peculiar use case, right? For any snap, ROS2 snap, you would only need the networking bits so that the ROS2 topics can flow easily in and out the snap. And this does not require any pre-approval. So you can push any ROS2 snap directly on the store. No gatekeeping there.
Any other questions? Okay, well, thank you again, Jeremy. That was a great presentation. Looking forward to seeing more people getting started with Gazebo with the simple way of installing it in their machines and trying out a lot of the available SDF worlds.
Right, thanks. That gives me the opportunity to recall that this is very much beta work, the packaging itself, because we want to hear from you guys. How do you use Gazebo? What are the shortcomings of the snap packaging? We have already identified one obvious shortcoming. We're working on it, but how do you guys use it? What are the roadblockers you've encountered? And if it just works, let us know as well. We would love to know. Just to give you a number, as of today, I've checked this morning, there are about 60 Snap installation. So that's 60 of you that are using Gazebo Snap and not complaining so far. So I guess it works just fine. All right. Thank you, everyone. Thank you for attending.
Oh, thank you, Jeremy. So we have some time to go over some of the news. So let me share my screen again real quick. So here are some Gazebo related news that Kat curated for us. So some of the cool ones, like if you guys haven't seen, there's a thread about memes about Gazebo on Gazebo community that you should check out. There was also, of course, the Gazebo snaps. And there's this cool underwater competition that happened inside Gazebo, the new Gazebo, which is really cool to see people in the community starting to pick up all of the underwater support that we're adding to Gazebo. And of course, there's the link to the meeting that happened last month, which was about marine robot simulation, and there are other things here. So does anyone else want to talk about something? We have a few minutes left, otherwise we can wrap up early. Okay, well, thank you again, everyone. See you next month. And remember, feature freeze is in a couple of days and code freeze is in a month. So see you all. Bye-bye.
Bye-bye.